Hello, good day. So before we proceed to our next topic, which is the pandas, so let us have a brief exercise on the NumPy library. Now this will test what you have learned from the previous lessons. So first, so let's proceed. So using a NumPy, so create the following matrices. So you can do this one, two methods. You can create the array, then you reshape. Second, you can go directly. So we'll do both here. So let me erase that one. So for example, so we have A is equivalent to np.array. So let's plug the values. So 3, -4, 8, and 5. Then we reshape this one into 2 by 2. So let's show the array. So we have 3, -4, 8, and 5. Next, we have np array. So we'll go directly here. So 2 square brackets. So 7, 8. So -1. We have 3, 6, 9. So we don't need to reshape this one. So this one is 7, 8, -1, 3, 6, 9. So the next one, so using NumPy arrange, so create the following array. So np dot arrange. So we have the starting, which is 2. So we'll end at 20. Then we have a step of 2. Then shift enter. So we have exactly the same. So next one, so we have np dot arrange. We'll start at 4. Then we end at 34. Then I think we have a step here of 4. Okay. So 4, 8, 12, 16, 20, 24, 20, 24, 28, and 32. Well, next one. So using NumPy ones, I'll create the following matrix. So C is equivalent to np dot ones. So this one is 2 by 3. Okay, so remember that one. So np dot ones. So I think again I'm mistaken here. So this will be a tuple. So this is ones. So these are 6, 5. So multiply this one by 5. So a NumPy array can broadcast to just like a list. So this one is the solution. So next one. So using NumPy linspace, so create the array below. So we'll use the linspace. So first one, np dot linspace. So I think this is 0 to 10. So spacing of 5. So 0, 2.5575. So next one, this is np dot linspace 2 to 20. Then we generate 10 equally spaced items. So this one, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So next one. So using numpy.run, so create 5 random numbers. So we'll use np.random.run. So we plug in the value of 5. So maybe you have a different result because this one is a random. So we created this one. That's a random number. So let me delete this one. So next, so using NumPy, so create a 3 by 3 matrix of random numbers. So the same thing. So np.random.run. So we create a 3 by 3. Okay. So shift enter. So this one is a 3 by 3 array or matrix of random numbers. So generated from 0 to 1. So next one. So let me delete this one. So next one is create the following NumPy array and then select the following sub-matrices. So I will not manually create this. I think I can see a pattern here. So let's denote this as D. Is equivalent to np.arrange 2, 66, 2. Then I think we'll reshape this one to 4 by 8. So I think we have some errors here. So D and P arrange 262. So dot reshape 4 to 8. So you cannot reshape this one. So from 2, I think this one is 66. So we have missing items. So let's see what's the D. Okay. So 2, 4, 6. So just the same. Then we will do sub matrices. So this one, if I show you again the D, so let's grab the value from 8, 10, 14, 16 up to 48. I think this one. So let me annotate first. So we will grabbing the value from here. So what will be the notation? So let's say we have D. So we start from the beginning in terms of row. We end up at index 3. Then from the third column, which is the fourth one, but this is index 3. Then we select forward. So we use Alt Enter. So as you can see, so we created this one 8, 10, 12, 14, 16, 24, 26, 28. Okay, so just like the given. So next one. So we select the sub matrices of 22. So this one 22, 24, 26, 38, 40, and 42. So we can achieve that by doing this one. So D. So start at the first index 0, 1, index 1. We end up at 3, then 2 in terms of column. So we end up at index 5. Again, this one is exclusive. So Alt Enter. So we have 22, 24, 26, 38, 40, and 42. Next one. So let me just delete this one. The extra cells. Okay, the code cells. So now we will select a portion of 8, 24. So let me just display again the original array so that we can see what doing here. So 8, 24, and 40. So selecting the specific matrix. So this one is D. Okay. So we have we start from the beginning of the row. So we end up at index 3, exclusive once again. So we select the column index number 3. Then we will reshape this one into 3 by 1. So this one is 8, 24, and 40. So let me delete this one. So next one, so subdivision 4. So we have 36, 38. So we have here 36, 38, 40, and 42. So let's select D. So we'll start at, I think this is index 2 in terms of row. Then 1, start at index 1. Then we end up at 5. Again, exclusive. So shift enter. So 36, 38, 40, and 42. So let's delete this one. So next one. So this is a bit tricky. So hint, use NumPy concatenate and NumPy transpose. So actually we'll be selecting portions of matrix that are separated. So this one 20 and 26. So how can you do that one? So for example, so division 5. Okay, so first we concatenate the specific array. So for example, np.concatenate. So concatenate means to add, okay, but not mathematically. So you add this one. So we concatenate, for example, let's do a multidimensional. So D, for example, then we have so 1 first row onwards, then we have column 1, then the next one we have D also. So we'll start at column 1 also, row 1 also, but we end up in index 4 in terms of column. Okay, so what does this means is this one. So let me execute this one. So let's see what will be the value of sub D5. So this one is 20, 36, 52, 26, 42, and 58. So that will be the array. So 20, 36. So what we can do here is to reshape the array. Reshape. So this one is the concatenate. We added 20, 36, 52. Actually not add. We concatenate 26, 42, and 58. So let's reshape this one. So let's say 2 by 3 and execute this again. So this one, so 20, 36, 52, 26, 42, 58. So as you can see, if we use the transpose, so we can derive this specific one. So np dot transpose. So we transpose the whole concatenation and the reshape. So shift enter. So this one, so 20, 36, 52, 26, 42, and 58. So let's delete this one. Let's proceed to matrix operation. So add and subtract the two matrices. So let's create the matrix. So np array. So we'll do directly here. So 5, negative 1. So we have 3, negative 4. So 8, 5. Then we have f is equivalent to np array. So 2, 4. Then we have negative 4, 8, 3, and 5. So let's execute this one. So let's see. So this one is E. So let's check if we have the correct values. This one is F. So I think we have the correct values. So in order to add this one, so remember np.add. So E and F. So I will alt enter here. Then we subtract. So np.subtract. So also E and F. So alt enter. So that's the result of the addition and subtraction of matrices. So next one, so multiply the matrix to the scalar value. So our scalar value here is 4. So let's create the array. So E is equivalent to np dot multiply. So we have np dot array. So I'm creating this directly. So 2, 4, 6. We have 1, 2, 3. Then 4, 5, and 3. Then we multiply it by 4. So we have a multiplication by a scalar. Oh, I think I'm missing a parenthesis. So again, so shift enter. So again, invalid error. So let's see what is the error on this. So we multiply this one. So I think this one. Okay, so we have an excess. So we have 4 times 2, 8, 16, so 24, and so on and so forth. So next, so multiply the following matrices. So let me create the array first, which is E. So np.array. So we have the following values. So 3, negative 2, 8, 5, 3, 2, 4, negative 2, and 4. So that's for E. So how about f? So np dot array. So we have 1, 4, 1, 2, -1, and 3. So shift enter. Let's look at the array. So this one is E. So this one is F. So alt enter. So now let us multiply. So remember, so this is the real multiplication. So we use dot E and F. So alt enter. So we have -7, 32, 6, 32, -2, and 24. So next, so find the transpose of the matrix. So we have G, for example, NP array. So 2, 4, 2 and 2, 4 and 5. So what will be the transpose of this one? So we'll use np dot transpose. So G. So this is the transpose. So the column becomes the row now. So 2, 2, 4, 4, 2, 5. Next, so we're using here the linear algebra function. So find the determinant of h. So let's find the determinant of h. So again, np array. So 1, -3, 4. So 1, -4, 1, -2, -3, and 5. So what will be the determinant of this one? Shift enter. So to find the determinant of this one, you use np dot linalg dot det. So that's for the determinant of a matrix. So alt enter. So our determinant is this one is -40. So next, find the inverse of a matrix and prove that it is the inverse of the original. Okay, so how can we prove that one? So remember, so if you multiply the original value of the matrix, you multiply it by the inverse, you will result in the identity matrix. So let's do that. So let's inverse this one. So again, so I is equivalent to np dot array. So 7, 3, 1, 0, 3, -1. So that's the value. So -3, 4, -2. So this one is the I. So let's find the inverse. So the inverse of I is equivalent to np.linalg. So remember I and v function, which is the I. So let us look at this one. So I and vi. So I'm displaying this one. So the inverse of this original matrix of I is 2, 8, -5. So these are the values. So how can we prove that this is the original? So again, so we can prove that one. So original multiplied by the inverse equals the identity matrix. So how? So can do this one. So the identity matrix is equivalent to np dot, so you multiply the original to its inverse, which is inv. So let's see. So this one is the identity matrix. Okay, so it doesn't look like the, because we have some precision, so we can do some typecasting here. So if you want to change the data type of the matrix, the value of the matrix, you can use as type, then NumPy. So we'll use integer 32 so that the we will have no precision. So use as type to change data type of a NumPy array. So let's execute this one again. So this one is the identity matrix. So notice the ones at the diagonal and the zeros above and below. So this one is an identity matrix. So next one. So we are asked to solve for the value of e to x here, e to the 3x. So remember, if we solve this one on the previous lecture, so let's e raised to the 2x is equivalent to 32. Remember, e can cancel this out by using a natural logarithm. So this will be cancelled. So this will be 2x is equivalent to ln of 32. So the value of x is equivalent to ln, okay, ln of 32, so over 2. And the application of natural logarithm in Python is the function log. So let's erase this one. So let's solve for the value of x here. So x is equivalent to np.log. So 32, so divided by 2. So the value of our x is 1.73. So next, so solve the following problems using linear systems. Systems of linear equations. So if twice the age of son is added to age of father, the sum is 56. But if twice the age of the father is added to the age of son, the sum is 82. So find the ages of the father and son. So you can do this by using a linear equation. Okay, so let me use markdown language. If you're interested, you can use this one. So $sign. So we'll be creating equation. So twice the age of the son. So I think let y be the age of the father. Okay, so 2y, so plus x is equivalent to 56. So let's execute this one. So I will execute this one as a markdown. So as you can see, so 2y plus x equals 56. So the second equation that we can derive, so if twice the age of the father, so I think 2x plus y is equivalent to 82. So $sign. So as you can see, this one is a system of linear equation already. So as you remember, we can solve for its solution by using the augmented matrix method. For example, we have matrix A is equivalent to np.array. So remember, our x is 1, our y is 2. So we can do this one. So 1, 2. So we have 2x and we have 1. So for the matrix B, remember the equation. So ax is equivalent to b, where b, our x is our x and y. Our b will be the constant, which is 56 and 82. And our a, so this one is the 1, 2. We have 2 and 1. So we'll just solve that using the linear algebra solve. So we have np array, we have 56, and we have 82. But this one is a 2 by 1 matrix. So let's add extra square bracket. So shift alt enter. So this one is matrix A, so matrix B. So how to find the solution? So the solution will be np dot linear algebra lin alg. So we use the solve. So we have matrix A, then we have matrix B, and let's show the solution. So the age of the father, so the father is older than the son, of course, would be 36, and the age of the son is 10. Okay, so if you substitute this one, so 2 times 10 is 20, so plus 36 equals 56. So that will be the missing variable. So another problem, so this one, so solve the following problems using a system of linear equations. So a Cub Scout is selling bags of popcorn. Small bag sells for $3. The medium-sized bag sells for $5. And a large bag sells for $7. The Scout has sold a total of 15 bags and has made $77. He has sold 2 more medium bags than small bags. So how many of each size did he sell? So again, this is a problem of a system of linear equation. So as you can see, uh, let's erase one. Let's erase this first. So let x be the, I think this one is the small. So y is the medium. Z is the large. Okay, so what can we derive from this equation? So let me just use a markdown here so that I can show you this one. So x plus y plus z is equivalent to 15. So the Boy Scout sold 15 bags in total. So that will be our first equation. So the second one, okay, he has sold, according to this one, he has sold 3 times, okay, which is 3x. Small bag sells for $3, so plus, so the medium sized bag sells for $5, so let's see, 5y. So plus the large bag sells for $7. So this one is 7c, is equivalent to $77. So that's another equation. So then we have another this equation. So he has sold 2 more medium bags than small bags. So 2 more medium bags than small bags. So let's say x plus y is equivalent to y. Okay? Or we can say that x minus y is equivalent to negative 2. Okay? So I'm using here equation. If you're familiar with latex, so this one you can denote equation in markdown by using dollar signs. So that will be our system of linear equation. I think I will not type or, so let's type comma here. So Alt enter. So we have x plus y plus z equals 15. Okay, this one is the first equation based from the worded problem. So 3x plus 5y plus 7z equals 77. So now we will compute for how many bags the Boy Scout sold, okay, or the Cub Scout. So this is a system of linear equations once again. So let's denote this as matrix C. So equals np dot array. So we have here 1, 1, 1. Okay. So let's go directly in creating the array. So we have 1, 1, 1. So the next one, we have 3, 5, 7. Then we have here 1. So negative 1. So there are no value for z. I can denote that as 0. Then next one. So we have the matrix D. So we'll put the constant right here. So np array. So we have 15, 77, then -2. So let's shift enter. So let's see. So this one is matrix C. This one is matrix D. Okay, so let's solve the equation. So how many did they solve according to sizes? So np dot lin alg dot solve. So we have matrix C. Another is matrix D. So solving. So the Cab Scout sold 4 small, 6 medium size, and 5 large. So if you add this one, 4 plus 6 is 10, plus Z is 5, totaling 15. So let's save this one first before we proceed to the next item. Let us proceed to the next item. So we are asked to find the eigenvalues and eigenvectors for this specific matrix EG. So let me insert some cells. So let's create first the matrix EG. So EG is equivalent to np.array. So we have 5, -3, -6, and 2. So this one is the EG. So 5, -3. So to solve for the eigenvectors and eigenvalues, so you use nplin alt.eig of EG, of course. So this one is the value. So our eigen value here is 8 and -1. The eigenvector of 8 is this one. So 0.7071. The eigenvector of -1 is 0.4489. So how about we derive the unnormalized version of this one? So remember from the previous lecture from a 2 by 2 array, so we can substitute the value. So this one be 5 lambda, 5 minus lambda. So this one is -3, 6, and 2. So if we substitute the value, so 5 minus 8, this one is -3, -6, 2. So the result is -3. So -3, -6. I think we have a subtraction here. So 2 minus lambda. So 2 minus, I think this one is 8. So this one is -6. So we have here -3, -3, -6, -6 equals to 0. So let's substitute. So -3x minus 3y is equivalent to 0. -6x minus 6y is equivalent to 0. So let's try this one. So let x is equivalent to 1, for example. So we have -3 times 1 minus 3y equivalent to 0. So -3 is equivalent to 3y. So let's divide both by 3. Then we have 3. So y is equivalent to -1. So the eigenvector of 8, the unnormalized version, so this one is 1 and 1. So eigenvector of 8 is 1 and 1. So let us prove that one. So how can we prove that one? So I will not erase this one. So what we can do is we find the value of the Euclidean form of this one. So remember, member. So we have, since this one is 1 and I think 1 and negative 1, sorry. So this one is 1 square plus negative 1 square. So this one is the value we're interested. So this one is the square root of 2. So let's see. So 1 divided by the NumPy square root of 2. So let's alt enter. So this one is 707. So this one 707. So another one, so negative 1 over NP SQRT of 2 also. So this one is the negative 1, which is a normalized value of negative 0.707. So as you can see here, so those are the value. So doing that again for the value of negative 1, let's do the same process for the other eigen value of negative 1. So again, so 5 minus the lambda, so negative 3, negative 6, 2 minus the lambda, so 5 minus negative 1, negative 3, negative 6, 2 minus negative 1, so 6, negative 3, negative 6, this one is 3. So 6x minus 3y equals 0. Negative 6x plus 3y is equivalent to 0. So let x is equivalent to 1. So we substitute. So 6 times 1 minus 3y equals 0. So 6 is equivalent to 3y. So divide both sides by 3. So our y is equivalent to 2. So for negative 1, so we have the eigenvector of 1 and 2. So let's find the normalized value. So this one is the Euclidean normalized value, 2 square plus 1 square. So we're looking here at square root of 5. So let us compute this one. So we have specific value, so 1 over the NP dot SQRT of 5. So the value here is 447. So this one, so 447. So another one, so 2 NP SQRT of 5 also. So the value is 0.894427. So I think this is the correct one. So as a whole number, so the eigenvector of 8 is 1, negative 1. The eigenvector of negative 1 is 1 and 2. So let me erase this one. So these are just very simple exercises. So before we proceed to the next topic of pandas, so I hope you are learning more and more as we proceed to the course. So see you for the next topic, which is pandas.